So in the previous video I was talking about the platelet number, okay, the platelet number disorders, and I talked about the immune mediated number disorders. Okay, I talked about the decrease in production and the increase in destruction and sequestration. Decrease in production, I talked about congenital and acquired diseases, okay, and the increased destruction, I talked about the immune mediated mechanisms like idiopathic thrombocytopenic purpura and the neonatal alloimmune thrombocytopenic. This video I'm going to continue my talk about the increased destruction disorders of platelets, okay, that will lead eventually to the decreased number of platelets. I'm going to talk about the wiskott-aldrish syndrome. Wiskott-aldrish syndrome actually is a syndrome that causes a defect in the cytoskeletal proteins that contribute in the production of lymphocyte and the platelets. So we have problem in the proteins. One of proteins that help in the buildup of platelets is an X-linked disorder, okay. The manifestations of the wiskott-aldrish syndrome is hypogammaglobulinemia, eczema, and the thrombocytopenia. So when you see thrombocytopenia, hypogammaglobulinemia, and eczema, you have to suspect wiskott-aldrish syndrome. How does the hypogammaglobulinemia manifest? It manifested by repeated chest infection, and eczema, okay. The thrombocytopenia is manifested as petechial lesions on this case. So this is a child with wiskott-aldrish syndrome. You can here notice the eczema on his skin. He probably have a chest infection and a bleeding or thrombocytopenia with petechial rashes. Okay, so this is petechial rashes due to wiskott-aldrish syndrome, thrombocytopenia. Here is the eczema, okay, on the face of the baby, chest infection, and hypogammaglobulinemia. So this is the wiskott-aldrish syndrome. This is X-link syndrome, okay. It affects the numbers of the platelets. Splenectomy actually will improve the case of wiskott-aldrish syndrome. Sometimes hematopoietic stem cell transplantation is the solution, so it depends. Okay, now let's move to the thrombotic microangiopathy. Oh, this is wrong. Okay, so it's thrombotic microangiopathy. Okay, and a thrombotic microangiopathy like thrombotic purpura, thrombocytopenic purpura, and hemolytic uremic syndrome (HUS), we have the end result is a decrease in metalloproteinase. Okay, this is a protein that contribute to the destruction of von Willebrand factor. So let's just draw it. This is a blood vessel, okay, and here we have von Willebrand factor. You remember von Willebrand factor that contribute to the adhesions of the platelets to the endothelial layer of the vessels, okay. The von Willebrand factor should be destructed by metalloproteinase protein. This is a protein to destruct the von Willebrand factor. What happens in thrombotic microangiopathy like thrombotic thrombocytopenic purpura or hemolytic uremic syndrome, that something wrong is happening with this protein, the metalloproteinase, okay. In the case of hemolytic uremic syndrome, we have a toxin like Shiga toxin or E. coli toxin that will inhibit the this protein, and this will lead to accumulation of von Willebrand factors. The accumulation of von Willebrand will activate the platelets, okay. So we have continuous activation of the platelets, and as a result the activation and destruction of platelet will lead to thrombocytopenia. Okay, and also in the case of hemolytic syndrome, the von Willebrand will accumulate, and this will destruct the blood vessels that trying to move in the blood vessel because of the narrowing of blood vessel due to the accumulation of von Willebrand factor. So in hemolytic syndrome we have a bleeding, okay, and the thrombocytopenia. I'm not going to get into details of this subject, but I want you to know that the same happens in this TTP, okay, but the difference is that in TTP we have no toxin to inhibit the metalloprotease protein, but what inhibits the metalloprotease protein is the is an antibody, okay, antibody. So we have accumulation of von Willebrand deposition and von Willebrand factor, okay, deposition of fibrin, RBC's destruction because of the narrowing, and activation of the platelets, so clearance of platelets, so thrombocytopenia. By this I end up the talk about the platelet number dysfunction, the thrombocytopenia. Remember always when somebody asks you about what things can lead to platelet number decrease, you have to remember that is three groups: the decreased production, the increased destruction, or the sequestration, okay. In decreased production, remember the congenital and the acquired causes. In increased destruction, remember the immune causes, okay, and the syndrome like wiskott-aldrish syndrome, the X-linked syndrome, a thrombotic microangiopathy, okay. Now let's move to the disorders of the function. Okay, I told you that we have problems with number and function here because the sheet is not that good to write here. I wrote down the things about the function down there, okay. So platelet function disorders, what things can lead to function disorders? Okay, deficiency in receptors on the platelet function disorders is all about deficiency in receptors on a platelet membrane to adhere, okay. So again, this is a blood vessel, okay, and this is these are the platelets here, a platelet, okay. These platelets, when we have a kind of bleeding, for example here, should adhere to the blood vessel, as I told you in the first video of this group, okay. So it adheres by attaching to the von Willebrand factor, okay. So this is the von Willebrand again, and the platelet should adhere here, okay. The receptor on a platelet that will attach to the von Willebrand factor and adhere to it is called the glycoprotein 1b complex, the glycoprotein 1b complex. So here we have glycoprotein 1b complex, okay. So it should adhere to von Willebrand factor. If we have a lack on this protein, so the platelet is unable anymore to land on the blood vessel. So platelet we have a bleeding here. If we have von Willebrand factors that are waiting for the platelets, but the platelets unfortunately have no glycoprotein 1b factor, so it is unable to land here, so it will continue into the blood vessel. So we will have a bleeding, okay. The red blood cells will continue bleeding without stopping, okay. This is the first thing. The deficiency in glycoprotein 1b complex, okay, is called the Bernard-soulier syndrome. The Bernard-soulier syndrome, remember it, Bernard-soulier syndrome, okay. This is about the glycoprotein 1b syndrome, okay. Now I'm sorry, a complex, not syndrome. The platelets, let's assume that we have platelets with glycoprotein 1b with 1b complex, okay, and this is a von Willebrand factor, and the platelet was able to sit here on the endothelial. You remember I told you that after the adherence of the platelet on the endothelial layer of the endothelial layer of the vessels, it should aggregate on each other. So a platelet set over a platelet and over a platelet and a platelet. So we have a complex of aggregation. Okay, but if we what helps or what contribute in this aggregation is the presence of glycoprotein 2p and 3a. So in each platelet we have a glycoprotein 2p. This is a glycoprotein 2p and 3a, and this is okay other platelet with the glycoprotein 2p and 3a. This will attach to the fibrinogen. Okay, this is a fibrinogen and this is a fibrinogen. Will attach to a fibrinogen to link each platelet with the other. Let's assume if we have a deficiency in glycoprotein 2b or 3a, so the platelet will not be able to attach to the other platelet. Okay, so we will have a case of landing of platelets, but we have no aggregation of platelets. Okay, so these fibrinogen receptors will not be able to attach the platelet to the other platelet. We have no aggregation and we have exacerbating bleeding. Okay, so this is the glanzman thrombaxenia. Glanzman thrombaxenia, I'm sorry, glanzman thrombaxenia. So remember the Bernard-Soulier syndrome. Bernard-Soulier syndrome is about the disability of platelets to land on the endothelial of the vessels. The glanzman thrombaxenia is an ability to aggregate the platelets over each other. Okay, the Bernard-Soulier syndrome is about the glycoprotein 1b. The glanzman is about 2b and 3a. Okay, the glanzman is milder than the Bernard-Soulier syndrome because we have landing but no aggregation. Okay, what are the clinical manifestations of these two syndromes? What are the clinical manifestations of platelet dysfunction syndromes? It's about the function of platelets, not the number of platelets. We have a mucocutaneous bleeding. Okay, mucocutaneous bleeding like petechiae, purpura, and so on. Okay, and we have also prolonged bleeding time. The bleeding time is a test that are target toward the platelet function. Okay, so if we have a prolonged bleeding time, so you have to know that we have a problem in platelet function. It is insensitive to mild to moderate platelet function disorders. It's only detect the severe platelet disorders. Okay, so if we have prolonged severe platelet function disorders, we have a prolonged bleeding time and mucocutaneous bleeding, epistaxis also, and so on. Okay, the final thing that may lead to platelet function disorders, the toxins and drugs. Toxin and drug or specific toxins and drugs can lead to platelet function disorders like uremia, valproic acid, aspirin, and NSAIDs. They all work in the shape of the platelets and lead to platelet dysfunction. So this is all about the platelet being disorders. Okay, in the next video I'm going to talk about the coagulopathy. Okay, I will end up the talk of the hematological disorders or hemostatic disorders by talking about the coagulopathy. Okay, so platelet is done now. Coagulopathy to the next lecture. Thank you very much for watching. See you in the